the next one is maintenance life cycle. So just as our software development life cycle, which is known as SDLC, software maintenance also has a life cycle. It is known as SMLC, and the main phases in this are just like our requirement gathering, planning, analysis, design, implementation and testing. We have the same for the modification request or the new features which is to be added. So first one will be the problem identification or the modification request part, and the second one will be the analysis of this request, and the third one will be the design phase, and then next will be the implementation phase, and then next will be the system test and the acceptance test. So we'll see in each phase what are the processes they follow. So first phase is the problem identification phase, uh, where they'll get the modification request, that is the change request, and assign an identification number to it, and then they'll classify the modification request based on which maintenance category it comes, like whether it is coming under corrective or predictive or preventive or adaptive. So they'll classify it, and then they'll accept that particular, they'll decide whether they have to accept the change or whether they have to reject the change. So they'll do all these process in the first phase. So what are the things? It is uh, it is assigning the identification number, classifying it into appropriate type, and then deciding whether to accept or reject or evaluate the request further. And the fourth one will be assigning a priority to each modification. So based on the priority, it will be worked on. The next is problem analysis phase. In problem analysis phase, they'll see what impact the modification will have, and what is the alternative solution for that particular modification request. This includes prototyping too, and then they'll analysis will be done on conversion requirements. If there is any change, if there is any change in the software product, what will be the requirement for that. So all those things will be seen in the analysis phase. They'll see the safety and security implications also. So suppose if we add a new feature, what will happen to the product safety and security. So how it will affect the cost of the product, whether it will be a short-term cost or a long-term cost, all those things. In Boehm's models also we have seen, right, what will be the return on investment. So they'll see that thing, and then they'll decide whether they have to accept it or not. And next is the design phase. So in this, they'll be designing the new feature based on the previous case. So they'll revise the previous cases, and they'll take the source code, and and they'll take the databases. They'll take the data structures, everything from the previous case, and they'll design for the new feature. Next is implementation phase. In implementation phase, they implement the source code, and then they document it in each phase, and the output of the design phase, it will be given in the implementation phase. So now the software feature is ready, so it is given for unit testing, and then they'll prepare a test review. So next is system test phase, where the software documentation is updated, and a review report will be prepared, and they'll check whether it will work with the different interfaces. So all those system testing will be done in this phase. Next is acceptance test. Here they'll create the acceptance test plans, acceptance test cases, and they'll create the acceptance test procedures. They'll evaluate the modified feature in this, and then they'll give an acceptance testing report. So it will be subjected to interoperability test also. Next is the delivery phase. In the delivery phase, the tested or the accepted system will be given for installation and training, so that we can verify whether everything is working fine or not. So this is the last step, or last step of the maintenance life cycle. So these are about the life cycle, which is similar to the SDLC. And we'll move on to the software maintenance engineering techniques. So software maintenance engineering techniques, we have three types. So maintenance techniques. So maintenance of software products becomes a tedious issue when there is no proper documentation. Because without the proper documentation, we cannot understand the design and how it is constructed. Sometimes there will not be any documentation at all. Even if there is some documentation, it will not be up to date. So without up to date documentation, we cannot go for a good design or good maintenance cannot be given. So some maintenance techniques are needed to be followed so that we can give a better maintenance to the customer side. So we have three types of maintenance techniques. The first one is re-engineering. So re-engineering is also known as reuse engineering. So the codes which are existing or the components which are existing can be reused, so that we can reduce the workload on the maintenance side. This technique is referred to as systematic transformation of the present software system into a new form to make quality improvement in operation, system capability, functionality, and achieving high performance at low cost. So, what are the steps involved in re-engineering? So, the system is reverse engineered, and it is represented internally for human and computer modification. Then it is corrected. The software of the system is corrected and it is completed. So it includes updating the internal specification and design. So the next one will be the new system which is generated. So some unstructured code, it will be specified into a structured code and then it is regenerated into a new system. So this is known as re-engineering. It reduces the cost, it reduces the risk, and it gives you better use of the existing staff, and it is considered as an incremental development because it reduces the cost in the sense it is making use of the one which is already existing. So one which is already existing, we know what will be the risk involved in it. So we can reduce the amount of risk involved in this, and the existing staffs will know the working of the code already. So it will give you a better use of the existing staffs, and this is considered as an incremental development because. It is using the available resources, it is using the available budget, and that is why it is working well with the organization. Next is reverse engineering. In reverse engineering, we won't have any proper information about the software product. So we'll be going from the back, and we'll be identifying the source code. From the source code, we'll be generating the required new feature. So this is an entirely different technique which is going from bottom up. So reverse engineering is like redocumentation, which focuses on providing information about the specification and design information using the software code. So it is a useful technique in software maintenance, which is helping us to understand the processes involved in the software system. So what are the steps involved in reverse engineering? So source code is first collected with the help of an automated tool for reverse engineering. This tool is then used to represent the structure and it helps in the naming of the functions, variables, and other components. So they use an automated tool and they identify all the data structures and what the functions used, everything. Then they go subjected to a statistic analysis, and then some standard structure analysis and design methods are used so that we can extract the information such as the data flow, control flow, and the entity relationship diagrams. So with that, we can extract the information, and we can arrive at the new feature modification code. The advantages are uh, if there is any information which is lost, then we can go with reverse engineering. And if there is any abstract information given in the source code, then we can use reverse engineering. And even if our documentation is incomplete or if it is out of date, we can go with reverse engineering and we can create our new modification for maintenance. It can manage complex software programs, because we are reverse engineering. We are not trying to analyze the complexity of the program or the product, and it detects the adverse effects of modification in the software system. So this is the advantage of reverse engineering. So the next technique is forward engineering. So forward engineering, it is just opposite of reverse engineering. So in this, we'll have ample amount of information. But in case of reverse engineering, we won't have documentation. It will not be up to date. So in those cases, we involve reverse engineering technique. Whereas in case of forward engineering, we have almost a lot of information. So the thing what we have to do is, we have to create or make an application with the help of the given requirements. So forward engineering is also known as renovations or reclamation, whereas your reverse engineering is also known as backward engineering, because it is the process of going in reverse to your forward engineering, right? So this is very simple. Having the existing requirements from the customer side, we are going to design a new feature. So this is very simple technique. And the final technique, we have seen about the maintenance life cycle, and then we have seen about the maintenance techniques. What are the types of maintenance techniques? All these things we have seen in this lecture. Thank you.